side, we're factoring n squared plus 6n plus 8. So remember, when we write it in factored form, here we're going to have not x's but n's, but our factored form will be n plus some number p times n plus some number q. So we're trying to find p and q to plug into here to write it in factored form. And we know, just like from what we did yesterday, that p times q has to give us the last term in our polynomial, the term that's just the number. So here that is going to be 8. And p plus q,
6.
it has to give us 6. Thank you, Allie. Why does it have to give us 6?
Because p plus q equals, I don't know, that's just how it works.
Where does the 6 come from?
6n.
6n. So 6 is the number in front of that middle term, the term that has just one n in it, the next one with 1. So p plus q has to give us 6, and p times q has to give us 8. So we're looking for the factors of 8 that also sum to 6. That's our goal. Right? So the factors of 8, I always start with 1 and go up from there. So 1 times 8 gives me 8, and 1 plus 8 gives me 9, not 6, not what I'm looking for. Next, I'm going to try 2 times 4 gives me 8. 2 plus 4 gives me 6. So, do 2 and 4 work for P and Q?
Yes.
Yes, they do. Does it matter which one I plug in for P and which one I plug in for Q? No, it does not. So I'm going to write this in factored form as n plus 4 times n plus 2. Question?
Do we have to, write them all out if we, know which one it is?
No, this is just the work to help me figure out what is my P and what is my Q. So a way to show your work here, if you just know it right away, is just to write 2 times 4 equals 6, and 2 plus 4, or 2 times 4 equals 8, I'm sorry, and 2 plus 4 equals 6. That would be showing your work on this. Okay. Great. So, Winter, what did you notice about number 6? That's different.
It's like a negative or a minus.
There's a minus sign in there. So what if P times Q has to give us on number 6? We have n squared minus 6n plus 8. What does P times Q give us? P times Q gives us our last term, right? What's our last term here?
8.
8. So P times Q gives us 8, so we're looking for factors of 8. And P plus Q is going to give us what? A negative 6. So we're looking for two numbers that sum to a negative number. So what do we know about, what does have to be true about P and Q for them to add up to something that's negative?
One has to be positive.
At least one of them has to be negative, right? But when we multiply P and Q together, do we get a positive or negative answer? When we multiply them
Negative.
together, what do we get? P times Q gives us positive 8. So at least one of them has to be negative, but what are the ways we can multiply two things together to get a positive number? We have a positive times a positive, or what?
Negative times a negative.
A negative times a negative. So what do you think has to be true about P and Q here?
They both have to be negative.
They both have to be negative. So we can again do our factors of 8, 1 and 8, and 2 and 4, but we can change them so that they are both negative. So now we have negative 1 times negative 8 gives us positive 8. But when we add those, negative 1 plus negative 8, we get negative 9. And we have negative 2 and negative 4. Negative 2 and negative 4 added together do give us a negative 6. So when I write my answer as n plus some number p times n plus some number q.
Wait, so we don't have to do for the other one, you wouldn't have to do n squared plus 6, 6x plus 6. You don't have to do the whole thing. You just have to do x plus 2 in parentheses and x plus 4 in parentheses.
This is the factored form right here.
Okay, that's solving.
But I'm putting that equal sign there to say that that is equal to our original polynomial. Yep. But what am I going to plug in for Q or for P and Q here?
Negative 2 and negative 4.
Negative 2 and negative 4. So I'm going to do plus or minus?
Minus.
Minus. So instead of having n plus q, I'm going to have n minus 2 times n minus 4. We can, again, multiply those together and double check that we do, in fact, get our original polynomial. But for the sake of time, we are going to go ahead and move on. But questions on number 6 here?
Nope.
Nope. All right, we're going to skip this chart and just move on down to number 7.
Actually, I do have a question. If it's like negative, is it always going to be negative, like minus?
We're going to see that. We're going to do a couple more examples.
Okay.
All right, so number 7, we're factoring x squared minus 5x plus 6. So, again, I'm looking for this in the form x plus some number p times x plus some number q. Again, like we noticed in the last example, p and q could be negative, right? So, what do we know about p and q here?
P plus Q is negative 5, P times Q is 6.
Exactly. P plus q is negative 5. Maddie, where did she get the negative 5 from?
The middle, because you have to add the two x's.
Exactly. The middle term that has just an x in it gave us negative 5. So when we add p and q together, we get negative 5. Abby, where did she get the 6 from? It's the term at the end. It's the last term, the one that's just a number. All right? So knowing that, we want the factors of 6 that sum to negative 5. So starting with our factors of 6, I always like to start with 1. We have 1 times 6. What else gives us 6 when we multiply it together? 3 and 2. 2 times 3. But we have to sum to a negative number here. So what do you think we have to do with our factors?
Make one of them negative.
Make one of them negative. If I only make one of them negative, what do I get when I multiply negative 1 times positive 6?
You get negative 6.
It's a negative 6. So can I only make one of them negative? They both have to be negative. So negative 1 times negative 6 gives me positive 6 when I multiply it together. So that part's good. When we add them, negative 1 plus negative 6, we get a negative 7. So can those be our values for p and q? No, they cannot. Again, I want to make 2 and 3 negative. So we have negative 2 times negative 3 does give us a positive 6. But negative 2 plus negative 3 gives us a negative 5. So do negative 2 and negative 3 work for p and q?
Yes.
Yes, they do. They sum to negative 5, and they multiply together to give us 6. So p and q are negative 2 and negative 3. So we're going to write this in factored form as x. And Danny, am I going to do plus or minus 2? Minus 2 times x minus 3.
Does it matter if you put the 2 or 3 first?
What do you think? If I switch this and wrote it as x minus 3 times x minus 2, when I multiply it together, will I get the same thing? Yes, so it doesn't matter which way. These are equal. All right, number 8. We have y squared plus 2y minus 15, and it asks us to factor. So we're looking for the factors of our last term here, negative 15, and we want them to sum to the number in our middle term, which is 2. All right? So what do we have to multiply together to get a negative number? Can we do a negative times a negative? Or a positive times positive? No. So we have to have what? One negative and one positive. So we can think of the factors of 15 as 1 times 15 and 5 times 3. Right? But I have to make at least one of those negative. So let's start by making one negative. I have 1 times positive 15 gives me negative 15. But negative 1 plus positive 15 gives me 14. This is not 2, so those won't work. So let's try switching which one we made negative. See if that works. Let's try a positive 1 times a negative 15. Will that also give me negative 15?
Yeah.
Yes, so you can switch which one you put the negative sign on. When I add those together, 1 plus negative 15, I get negative 14. So those will not work. All right, so next we have 5 and 3. So Jack, which one do you want to make negative? The 3. All right, so we have positive 5 times negative 3. When we multiply those, we do get negative 15. And when we add 5 plus negative 3, we get a positive 2. So do those work for our values of P and Q? Yes, they do. So when we write this, we're going to have y. And are we going to do plus 5 or minus 5 here?
I did
Plus.
minus 5.
I
Plus
did
5
plus.
minus
I said minus 5 plus 3. It's the same.
All right, so when we added them together, we added positive 5 plus a negative 3. So since we added a positive 5, are we going to do y plus 5 or y minus 5? Plus. So in this case, it does matter if we make this a plus or minus. But we added 5 plus negative 3, so that means we're going to do y minus 3. So would this be the same if I wrote y minus 5, y plus 3? No, that is not the same. So it does matter if it's positive or negative. Right, questions on this one? Alrighty. Let's go down to, we're going to skip to number 10. And I want you to add an equals 0 on the end there. Guys, this way. Number 10. We have x squared minus 7x minus 30 equals 0. And I want you to change the instructions. Instead of saying factor, I want you to say solve. So, again, Alex, whenever it tells us to solve, what are we solving for? We're solving for x because x is our variable here. So we're solving for x. So remember that. So our answer should look like x equals something. Okay?
Is this the greatest common factor thing?
This is not using the greatest common factor. So before, you're right, yesterday, I think it was yesterday, we factored out the greatest common factor and then solved for x. Today we are going to factor the polynomials and then solve for x. Okay? So just like we've been doing, first step, we're going to just factor the polynomial. So our polynomial is x squared minus 7x minus 30. So to factor that, we need to find the factors of negative 30 that sum to negative 7. So Danielle, give me two factors of 30. 1 and 30. But we need to factor negative 30, so one of those has to be negative. So let's do negative 1 times 30. When we add those together, we get positive 29. So 1 and 30 aren't going to work. What are other factors of 30 we could use? 3 and 10. Right? But again, we need to factor negative 30, or multiply negative 30. Sorry. So we have to make one of these negative. So let's try making the 3 negative. Let's do the 3 negative first. Whenever we do negative 3 plus positive 10, we get positive 7, but we're looking for negative 7. So what can we change so that we have a negative 7?
Make it a negative 10.
Make the 10 negative instead of the 3. So 3 times negative 10, when we add those, we do get negative 7. So we have found our values for P and Q. So we're going to write this as x plus 3, because we use a positive 3, and x minus 10, since we use a negative 10. But again, this is still equal to 0, because we've rewritten that larger polynomial into two smaller polynomials. So when we solve, now our next step is just to solve for x. Okay, so you guys have done this before. We want to take each of those polynomials and set them individually equal to 0 and see what we get for x. All right? So go ahead real fast, and everybody, you're going to set x plus 3 equal to 0 and x minus 10 equal to 0. And what are you going to get whenever you have x plus 3 equals 0? X equals negative 3. And when x minus 10 equals 0, to solve for x, we move the 10 over, and we get x equals positive 10. So our solutions here are negative 3 and positive 10. Questions on this one?
How do we do that?
How do you do which step?